Okay, so that's 10 past, so I think we'll get started. So, unfortunately, the team member that was going to give this talk, Yang Zhang's unable to travel today, so I'm going to try and give it in her stead. What I'm going to talk today is about auto vectorization for the AArch64 and the C2 Hotspot compiler. And so I'm going to start off with some history, go through what's already there in Neon, and then go through on how to add an instruction, and then go through some potential enhancements that could be added. So first of all, if you've been to Linaro Connect before, you'll know there's been some talks on OpenJDK before, given by my predecessor Ed. So in 2015 there was a couple of talks on both of them. I recommend you read them if you've not seen them before. We go into more detail as to how the AArch64 was done. Now, vectorization support was added quite recently to Hotspot in 2012 using superword level parallelism. And soon after that, in roughly 2015, support was added to the AArch64 port for 128 and 64-bit wide vectors. Now, we don't support everything just yet in the AArch64, but this covers quite a good amount. Notable absences include the loads and stores of interleaved vectors. But what we do cover is simple loads and stores. We do some reduction arithmetic, so you can do totals at the end of your vectors. And of course there's some general arithmetic and shift. There's a whole load of instructions are included to do with narrowing and widening. We'll talk a wee bit more about that later. Now, there are two parts to the work that's done. For AArch64, there's obviously, you have to have the instruction within the back end before it's even emitted. So some emission to be done there. But there's also, in this blue box, well, blue circles, there are the mid-level parts of the compiler that would need to be changed in order to get support. In terms of the history of things, that all of this was, we were kind of looking at this during the shutdown of JDK9, which is when this work was done. Unfortunately, well, we could potentially have added some back-end specific changes. The mid-level, the common code between all the architectures was not open to us. But when we're going through this, it's a case of adding instruction, adding a rule for it to match certain patterns in the compiler, and then adding the classes and the operators and the nodes before then testing it. So just to frighten you with some code, there's the here's the encoding for the actual instruction. I say encoding. The back end for C2, well, the C2 compiler has what's known as an architecture description file. This describes how the instructions are generated, how they're matched up with the graph, and if you look here, we can see how there's a disassembler added. Now, one of the important things to watch is this match instruction here. That's matching the graph that describes the program and saying at this point here, we'll be able to emit this instruction. So given a vector, source 1, source 2, and a destination, in that order, emit this instruction here. Now this will become important looking at this instruction here. So the multiply load instruction, well, multiply add instruction was already existing in the back end. And what Yang found is that it wasn't actually being emitted. So it had instruction, it seemed to have the match for certain cases, but we weren't actually optimizing it out. Here we can see the multiply and an add, and in principle, because we have the instruction, there should be the multiply accumulate, well, multiply add instruction following that. Now, so that's just a description of what I've just said. So there was two ways of going about this. The first patch was purely in the AArch64 code. And so what we were doing was, there was two sources and a destination. We were only matching the instructions in that order, where those two sources fall by the destination. This added the destination first. So in terms of where the instruction flow is going, we weren't picking up the common case. So a better solution would be to make the add nodes commutative. But unfortunately that would require it to be done in the common code, which was not able to be merged at that point. So with any luck, once that's been refined, the instructions should be added to JDK10 and backported to JDKU. Another situation was with byte neon instructions. Now in principle we could emit loads and stores and vector adds for byte instruction, but what we actually found is that C2 wasn't emitting these. Instead what we have is just a simple load 2 bytes, add the bytes, store the bytes. What's going on there? Now what was actually happening is that because of the way that superword level parallelism works, there's a dependency on the loops to be unrolled sufficiently to then do the vectorization. And unfortunately, the limits that are set on the compiler are such that we're not unrolling the loops enough. So in principle we should have 8 or even 16 bytes loads and stored and added, but we are not actually unrolling enough. So this is something to discuss later. Another instruction that we don't do, and this is stuff that we have still to investigate further, is to do the interleaved loads and stores. Quite common and powerful instructions. Now, well, we could add support for LD1 and ST1. There's no support yet for the equivalent instructions in x86, so it might be straightforward enough to do that. Supporting the LD2 to LD4 instructions is going to be quite a bit more challenging, so that's what I believe we'll be getting Yang to look at next. If you're not familiar, there's also the vector, long, wide and narrowing instructions. I don't know quite where we are with that just yet. These are quite complex instructions to match, and of course we'll see where we get with that. So another interesting one is the byte and short support. So I've mentioned before about the rolling and unrolling. One of the challenges we found with that is that this is similar to, well, the actual Java virtual machine doesn't know about bytes and shorts when it's doing calculations. When we're loading bytes or loading shorts or storing them, we're lengthening and shortening them from integers. The VM works on integers. And one of the problems we've found is, as well as the unrolling and ununrolling, the bytecode itself doesn't necessarily tell us whether or not we're dealing with bytes or with shorts, and so the limitations put on the loop unrolling and such like isn't done for bytes and shorts. So whereas the compiler thinks we're dealing with integers, it will unroll so far, and it doesn't know to unroll any further using bytes and shorts. So that's another piece of work's been done. The latest news is there are some patches being discussed just now on the mailing lists as to recognising this, but that will be done at the JDK10 timeframe. So that was rather fast. It was quite a short session. But are there any questions? Shall I? Sorry, microphone 2 or 4 didn't.
Thank you. I wonder, compared to other instruction set, does AArch64 offers more powerful feature for the JVM hotspot virtual machine to do more powerful virtualization, vectorization?
It's hard to tell without an in-depth study. I know Yang has compared the two. Fortunately, that's not in my head just now. The LD2, LD3, LD4 apparently isn't quite the same on x86. And there are, certainly for things like maybe SSE3, SSE2, there's more powerful string instructions that aren't present in Neon that would be quite good in Hotspot. To answer your question.
Thanks.
Thank you. Can you please move back to the last slide?
Yes.
What I'm about to ask is, so it's not my idea. Can you? I just saw it on the QEMU list, TCG implementation, but it was about the same problem basically. That so here the problem is that you cannot chain these shorts and bytes because the addition would carry on, right? The carry bits to the next bytes and shorts at higher offsets.
No, this is to do with the type handling in the JVM bytecode. So in the loop here, you would see a series of adds or subtracts or whatnot on integer types. And the compiler doesn't have the wherewithal just now to know that it's dealing with actual bytes and shorts. And so it doesn't unroll enough in these instances to do the proper vectorization.
Oh, okay. Thanks. I thought it was a limitation in the instruction set, but so it's one level higher up, right? Because the
this is the middle end that was
Thanks.
not handling it quite right. Well, if there's no more questions, thank you very much for your time.